So thank you so much. Thanks for the opportunity to be here. What I was wanting to talk about and share today is what we're doing with QoS and even extending it, because QoS is just what we're doing on the network. We want to extend that to include what we're doing on endpoints. And then we're dealing in the area of QoE. Quality of experience is an even broader superset of QoS. And then finally, we're also developing a set of technologies and solutions for validating that entire experience. So this is what I wanted to share with you today. So as far as an agenda, I wanted to just overview some of the customer concerns that we keep getting, and so that we know that we're addressing them and delivering what the customers are asking for. And then I invite your input to see, okay, did we capture most of the salient things? Are these the things that you're also running into? As well as then, perhaps other things that we haven't heard from. Giving us that feedback is very, very important, because some of these solutions are early on, and the earlier we get the right guidance and direction, the better we're able to meet those customer needs. Then I'd like to talk about how we're evolving our hardware and likewise our software. I have a little UADP ASIC here. This is the heart of the 3650, 3850 switch. It's the heart, brains, muscle, everything you want. And it's an incredibly powerful chip. I'll talk a little bit about that. I talk a lot about that. Actually, yesterday I did a session called The Blood and Guts and Gore of QoS, and then we spent a whole half an hour just on how this little puppy does QoS all the way inside, and it's really impressive in my opinion. I'll also share what we're doing in software to not only leverage the power of our hardware, but then to simplify it, because this is something we get from our customers saying, make it simpler. Tom was saying that, yeah, some of the sessions can get pretty overwhelming and intense, and we don't want that. We have a lot of power, but we want to make it simple. So that's the challenge there. I'd like to share what we're doing to automate that, as well as then our direction going forward in this whole area of validating the experience. Does that sound good? Okay?
Definitely.
So when we talk with customers, well, we see that almost every customer is looking to increase their overall productivity in various ways. So they have collaborative applications or other critical applications or customer-facing applications that they want to have high levels of experience. And to enable that, we have to appropriately design the QoS policies throughout the network to enable it. And it has to be end-to-end. It's just like, I often use the analogy, QoS is very much like a chain. It has to be end-to-end with every link cohesively, compatibly interconnected, otherwise the chain just breaks and you're left with a useless technology, a useless solution. So this requirement actually is the reason why QoS is the second most widely deployed network technology in the enterprise. It's second only to routing. And we know this because we have telemetry info from over 200,000 devices that customers have shared with us, and we see the amount of technologies and features they've turned on, and we see that, wow, QoS is very, very near the top, second only to routing. Well, you got to be able to have your network working, but then overlay it with QoS. And so these are the reasons that customers deploy QoS so widely, but they find it challenging. This is not uncommon where we get comments like this, that it takes us months to roll out a QoS policy. It takes an awful lot of time because we have to validate these designs, we have to test and make sure that we got the right configs on this platform, that platform, and everything's going to work systematically end to end. And then we have to schedule the downtime to roll all of this out globally. Even in Cisco, with all our expertise, with all our CCIEs, with all our tools, we just had to make a 2-line change to our overall policies to onboard Jabber. It took us 3 months to do it. This is it's too complex. So what have we done and what are we doing to simplify this, to automate this, to expedite this, is what I'd like to share as well. And then this is very interesting feedback. So we're saying, okay, beyond just pushing out the policies, what other challenges are you having? So in the design and deployment, we've been doing a lot of work there, and I'm going to share some of the things. And Ramit, who's going to follow me, will talk even more in depth, for instance, of our EasyQos Solution, which is an app on top of APIC EM that pushes out QoS end-to-end with just a single click, according to our Cisco validated best practices. But excuse me, even after we've pushed it out, what are all the challenges? Customers are saying, well, how do I know it's working? Where's my ROI? If I have to put $1 million into this deployment, show me that I spent my money and time well, and give me that feedback. So give me that performance, give me the telemetry, show me that the applications are working better. The challenges I'm facing, according to the customers, is that I have too much data. I have, I got NetFlow, Perfmon, Armon, I got SNMP MIBs, I got syslog, all of this information, and it's so hard to correlate and extract meaning from it. How do I really understand what's going on with respect to my applications and their performance? How do I baseline my network so I know what's normal for an application performance and don't overwhelm me with a whole series of alarms that are false, as well as give me a single pane of glass. This was a recurring comment I thought was really funny. Everybody blames the network.
Never heard that before.
You never heard that before?
It doesn't happen.
It's almost like the network administrator is default guilty until he can prove himself innocent and then point the finger at someone else.
Have you heard the expression means
security? So
What's that?
everybody knows it's actually security.
Have you heard the expression mean time to innocence?
What's that?
You heard the mean time to innocence.
Yeah. No, I haven't.
Yeah.
But I'm gonna put that in too. I
I'm
think
hearing
that's great.
network products being pitched with that, actually.
Yeah?
They're talking about mean time to innocence being shortened, yes.
MTTI?
MTTI.
Okay, awesome. I like that. So it's very, very common. We get that report, and it's like, we just have to figure out what's going on. But more than just past blame, you definitely want to get to that root cause. And if you can correlate, we have tons of information available, and we'll talk about that in a little more detail. But if you can extract the right meaning from that information to find that root cause of what's going wrong and do that effectively and quickly, that would be, what we're hearing from our customers is that would be very valuable. So we're looking at how we can attack that, and I'd like your input as we get to that part of the conversation. Our high-level vision given to us by our SVP, Jeff Reed, in Enterprise Networks is to transform our customers' business through powerful, simple networks. So they're transform not the network, but the business, along the lines of, say, what Uber is doing to transform the taxi business. So, for instance, we were in Cisco Live Berlin a few months ago, and then we used a Uber-like application that they had there, and it was, phenomenally simplified and valuable to us for many reasons, not just the basic Uber functionality. Like, first of all, it's Berlin and it's the middle of winter. I don't know why they send us there in like January, February. It's bitter cold. And then about 13,000 people leave the conference all at the same time. That conference center is nowhere near close to hotels like this. There's no hotel within walking distance. Everybody needs a cab, and it's incredibly cold. And these lines are as long as you can imagine. Well, you get this app. You not only get the taxi to come right to you, you bypass the line. It breaks the translation barrier because these German streets are like 17 syllables long, right, in their names. And you're like, Gubenduberstrasses, right? And they're like, what? And then you're having that whole thing. And then not only that, you don't have to deal with the currency exchange. So all of this is enabled through the power of digital technologies, leveraging the networks to connect all of this stuff so that we can have a whole new transformed business. So that's the overall intent. Now, the approach is a two-pronged approach, powerful yet simple. We've been traditionally strong at doing powerful solutions. We've been traditionally, candidly, very weak at making them simple. We often make them, it's like, hey, look at all these nerd knobs we're giving you. You can tune them this way, that way, the other way. We're going to write you CVDs that are yay thick and then give you all these options. But the customer feedback we're receiving is, we want this simpler. So we're going to show you some of the things we're doing along those lines. And then finally, what is it we actually build our networks? To that end, this is our new architecture for enterprise networking going forward for the next 5 to 10 years. The overall vision, the digital network architecture. I'm sure you guys have seen this already or been introduced to it. Okay. So the areas that I'm going to deal with primarily are what we do at the infrastructure layer, physical and virtual, automation, and then what we're doing, researching and developing in the analytics area. Some of the key tenets and principles that I really appreciate is that everything has to be open, programmable, standards-based. We cannot lock out the network. That is very clear feedback we're getting from our customers. Don't even try. Even if you can do a better solution, it has to interoperate, it has to be multi-vendor, has to be open and standards-based, and we're like, okay, got that. We're going to make it that way, and that actually gives you more power and flexibility to your overall networking options that you present to customers. You say, okay, it's not like an either-or decision, you can have and. You can have this, and you can have another party vendor here, and they'll still work, and they'll still interconnect. Another thing that I really appreciate is the open APIs. We definitely want developers to connect and to interact with our automation platforms, APIC-EM, for example. Excuse me, bear with me, please. So that they can write their own apps that talks to the network, and we'll show examples of that, particularly in EasyQos. Any application vendor can talk to EasyQos, and then the QoS requirements for that application can be deployed in real time. I think that's really powerful because it's kind of like when Apple opened up the iPhone to say, any developer can now develop to it. You have a lot more potential, a lot more possibilities than on leveraging new solutions that are custom tailored to anyone's given environment. So those are some really key tenets or principles that are embedded in this architecture that we're driving now. So let's talk about hardware first of all. So the more I look into our hardware, the more impressed I am with it. I'm just going to build up these slides because I don't have a clicker. Okay, pardon me. So a quote from a leading computer scientist named Adam Kay about, 30 years ago was, people who are really serious about software should build their own hardware. You might have heard this quote because it was often stolen and repeated, made famous by Steve Jobs, and that became a mantra for Apple. And then we also believe in this principle as well, because if we want to have very powerful software solutions operating at line rates at these, giggy, 10 giggy, 100 giggy campus rates, we have to build powerful hardware. And we absolutely do. So for instance, two ASICs in particular that I'd like to call out, the UADP, which is what I'm holding here in my hand. Again, this is the heart and brains of the 3850. The master principle behind it that's so powerful is that it's fully programmable. This chip, when it was designed, it doesn't even know what an IP packet is. It has to be told how to recognize an IP packet, how to treat it, and then deal with it. And the advantage there it might be counterintuitive, saying, well, why would you do that? Well, the thing is that there's new protocols that are constantly being developed, and it takes about 3 to 5 years to spin up an ASIC and to have it ship out, whereas we can just add new protocols in microcode to this chip, and then suddenly we're able to recognize Lisp or VXLAN or whatever else, and keep on evolving and perform a lot of functionality in hardware at line rates without waiting all those times for new provisioning. So for instance, at this networkers, what we're also featuring is, for the first time, first time in a long time, we've got NBAR back in the campus. So we have NBAR, our network-based application recognition, 1,400 applications in our latest NBAR library that can be classified and marked and treated for QoS purposes at line rate in this little guy right here. And it's incredibly powerful. So that kind of functionality is made possible by building our own hardware. The quantum flow processor, that's in the heart and brains of the ASR series routers. And so again, it's some very, very powerful ASICs. For instance, it has two components. One component is called the packet processing engine, and that has 64 of these PPE engines within it. And each one of those engines was the equivalent of our 7200 series router, if you guys remember that, right? So 64 of that 7200 series router, pretty decent beast in its day. It had a good long lifespan.
I know people who still run them.
Exactly, right? 64 times happening right inside. And then in addition to that, it has over 100,000 hardware queues at 5 levels of hierarchy that you can achieve. So, the physical rate, you can then shape, to your service provider's contracted rate. You can shape on a per branch basis. You can shape and queue on an application basis. And then on top of that, you could even shape and queue and have a policy based on users, applications, sites, service provider contract, and then physical line interface. So just phenomenal amount of power and flexibility, all enabled within the hardware. And again, I spent about another half an hour going into the guts of that on this blood and guts and gore of QoS session. That was a really fun session. Now, software. So now that we have this power, right, we said our overall approach is dual-pronged, powerful but simple. How can we leverage this power without overwhelming customers? Because one of the biggest the biggest obstacles we hear is the complexity of turning on QoS, for example. It's like we know we have to have some QoS, some minimal QoS often, but we don't want to go down too deep because it just gets too complicated too fast. What have we been doing to simplify this? So I have a question. How many lines of CLI do you think it would take to configure an industry standard? Remember, everything has to be standards-based. Best practice QoS configuration for 1,400 applications.
The record so far is 3. Let's see you beat it.
And I will.
Okay.
And I will. And I
Challenge
will.
accepted.
Okay, that's awesome. I love that layout. So I saw the previous session, they had 3 lines of power. Okay, so to start with, again, I'm going to just set it up. The relevant industry standard here is RFC 4594. It outlines 12 traffic classes of different types of media that have unique QoS requirements in your enterprise. So 1,400 applications into a 12-class model. In the CLI, prior to this was an exercise. This was a fun exercise to do. So prior to 15.3, it took me 1,622 lines because we had limitations such as you could only do 32 match protocol statements per class map, and then you keep on adding until you get to all 1,400 of your applications, and then you have to do hierarchical class maps to combine the overall policy, blah, 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 blah.
Does that fit in the NVRAM?
Yeah, exactly. So I think we were doing an ASR, and so we fit that. Okay, so that was our starting point. Okay, this is just a year ago. And incidentally, I'm going to say this too. We've done more to advance QoS technologies in the past year than in the previous 10. So I'm extremely proud of that. I've been very happy and honored to be involved in that. And so this was, a year ago, this was a situation. If you wanted to leverage the power of our network-based application recognition library and engine, it would take you this amount of complexity. Okay, so we started to abstract that. We said, okay, why don't we group these applications together according to these QoS classes, and then the overall policy goes along the lines of, I know it's a bit faded because I wasn't sure of the level of detail we're going to get into, but basically you say a match all statement that says both of these conditions have to be true. The first condition is match the traffic class voice and make sure it's relevant to my business. And that business relevance setting you customize. You can set any way you like. We'll default set the applications based on the telemetry we received and seeing how customers are deploying certain applications. For instance, in most enterprises, Skype for Business would be considered business relevant, but regular Skype would be considered business irrelevant in most cases. Not always. If that's not the case in your particular organization, it's a one-line change. You say make Skype, regular Skype, business relevant. No problem. Then this policy captures all of those applications. It abstracts them. And then the other huge advantage of this is that this policy never changes, which is tremendously powerful because if you have like 500, 1,000 branch routers, and then we update our protocol packs every month now. And now you have a new protocol pack with new applications and you want to leverage those new applications. Do you really want to go out and change and touch 500 sites to 1,000 sites or whatever you have? This policy doesn't change. I call this policy the Holy Grail QoS classification marking policy. So it's scalable, it's relatively simple to understand. It's like, okay, this is my traffic class and it has to be business relevant. This is a policy I want across all our devices. It's already supported on routers. It will be supported on switches starting 16.5, iOS XE 16.5. This is also what we're going to do on our wireless LAN controllers. So holy grail, one policy across the board. But like you said, we're still at 114 lines. And I got to get under 3. Here goes.
One policy to rule them all?
There you go. So these two policies as a classification and marking on the LAN edge, and then classification based on diff-serve code point, and your queuing policies based on Cisco validated design best practices. 2 lines of CLI to enable classification, marking, low latency, priority queuing, class-based weighted for queuing, WRED, fair queuing pre-sorters. Very, very powerful overall solution, but made simple. Is that cool?
What was the original number? 1,100 and
1622.
1,622?
Yeah.
Ooh.
Yeah, so that's the kind of things we're doing. This is coming. We've already got the templates. This is in development. We're giving you a heads up of where we're going, what we're doing.
And this is going to be consistent across switch lines, router line.
Yeah, that's what we want. We like that
Yes,
holy
thank
grail
you.
is going to be across exactly.
I know
across
things
the
been
board.
moving that way.
Yeah.
MQC on switches
Yeah.
and all that, like, but
Exactly.
that's been
The other thing too that I might be of interest to note is that when we do QoS in hardware, that QoS will vary according to the hardware. And right now, even the variation in hardware, all the different ASICs, like we have Doppler on the 3K, on the older 3750s, we had an ASIC called Strider. On the 4500, we have an Earl family of ASICs. We're up to, I'm sorry, K family. So right now it's K10 on our 6500s, and that was the Earl family, and that's up to 8 and 8.5 on the 6800s. So we have all these different ASICs, and then QoS is done differently, and on the 6500 family in particular, QoS was done differently on every line card. You know, we had like 32 different hardware queuing structures on those different line cards. Within the next 5 years, our goal is to get down to 5 queuing structures across the whole Catalyst family. So we're picking a very, very powerful queuing structures, but we're also then making it consistent across the different hardwares. So that will also facilitate things, but nonetheless, we're abstracting that even in software today. So even if you have different hardware, we can fully abstract what's happening underneath by what you have to program at the CLI level.
Yeah, so you're saying 5 queuing structures, meaning that the ASICs handle them differently depending on which platform you're on.
Exactly. So
But
5 different hardware
configuration-
queuing structures depending on, say, there's things they have to take into consideration, such as the price point of a given ASIC,
Sure.
so that capabilities then will likewise vary. So what you could have at the access, you know, you'd want perhaps, you know, at the high-end core switch to have more functionality. And so there's going to be a few different variations, but not 50.
Right. I'm just thinking templating configuration. So
Yes.
the idea is that because it's abstracted, it's going to be the same to us as an engineer for
Exactly.
deploying it.
Yep.
But the hardware handle it according to what it can do.
Exactly.
Oh, perfect.
Exactly. So then, going forward, how can we even automate this further? Because this still requires me to touch CLI, 2 lines of CLI. It's a lot. Well, I'm just kidding.
that down to
But if I have to do that down, let's get that down to 1. Okay.
Next
Well, we
session's
could.
got to
Why
target
not?
1.
Why not? Okay, one autocross command.
Or next presenter.
Yeah. But then rather than touching each device, even if we have to touch it with 2 lines, if we have hundreds or thousands of devices, what can we do to simplify that even further? So automating our policies. So our platform for automation within our architecture is the APIC-EM. So Application Policy Infrastructure Controller Enterprise Module. This platform, we can have different apps on it. Like I said, we encourage application development. Just like, you know, Apple, when they opened up their OS for developers, they can develop their own apps and then leverage all those APIs directly to the network. It makes for solutions that are greater than anything we can achieve on our own. A really powerful, let me see, what's the right word? A really powerful element that the controller brings to the solution is policy abstraction. Like right now, if you want to configure QoS end-to-end, you really got to know your stuff. We have the latest book that I wrote on it was 1,042 pages, right? And it's like it'll put people to sleep if you have to go through a book that's that thick to figure out how to do it end to end. We don't want that anymore. We don't want our operators to have to go to that level of technical reference or to go to an 8-hour or 2-hour breakout session or multiple 2-hour breakout sessions depending on the platform, depending on the place in the network in order to deploy QoS. So we want policy abstraction. So at a very, very high level, the operator says, these applications are important to me. Those I know are not, and the rest I don't care about. 3 levels of what we call business relevance. Business relevant, that's important. Business irrelevant, that's the entertainment, consumer, Netflix, Hulu, YouTube, all that stuff. And then there's all the stuff I don't care about one way or the other. Ramit, who's coming right after me, will show you in more detail how we've implemented that in the GUIs. And it's a very, very simple expression of your business intent. Then we take all of that and translate that into device-specific CLI. So the operator expresses his intent. We can even talk directly with applications. These are open APIs. So for instance, we have APIs talking to our call manager. So the call manager says, hey, I got a voice and video call. It's going up right now. Set up the QoS, and we'll set it up end-to-end before they get the phone to their mouth and start saying hello. But because it's open, Microsoft Lync has already taken advantage of it. And Avaya, working with third-party Nectar, is also doing a solution there too. So it doesn't have to be a Cisco on Cisco solution. It could be, this is the open, the value of keeping everything open. You can have so much more options in your network. And then in the southbound direction, we've programmed that application with basically all the knowledge in our CVDs, in those books, for example. It knows not only the capabilities of every device in the network when it comes to QoS, but also the Cisco validated best practices. And this is huge because if you think about combinations, so if you have, for instance, you have, 6 combinations, right? Then the permutations is, n times n minus 1 over 2. So 6 times 5 over 2, you have 15 combinations. The more features you have, the greater factorially this combination becomes. We have 2,500 features in our Catalyst toolset right now. If we had to test every one of them in combination with every other one, the number is beyond, like, I saw a screen, it was just like zeros all the way across the number of permutations. So the point of our Cisco validated designs is that rather than leaving customers to test these best practices or to test what's the right way to turn on QoS systematically in conjunction with all the features they already have turned on in their network, we do extensive stress testing, scale testing, systems testing. We have labs that are got more than $100 million worth of gear that are outlined and laid out the way our customers' labs are with real traffic running on them, as well as additional amount of overlay synthetic traffic to just pound the garbage out of it and to make sure all of this stuff works. That's the kind of designs we program into the controller so that there's this, we take a lot of the risk of deployment out of the equation for the operator. He says, okay, what is the best way to configure QoS on this box to meet this business requirements? We've already got all that knowledge embedded into the solution. That's actually a big important point there. So it really speeds the market. The other thing I really want to touch on, and Ramit will go into it, we also had the mandate of supporting brownfield. So a lot of our competitors, they're saying, okay, you want an SDN-based solution, you got to go greenfield, you got to do a forklift upgrade. Our customer feedback was that's not going to be an option for us. Make it happen with what we got. And so that was a real challenge that was thrown to us, especially doing things like dynamic QoS and how to make it work on architectures that were never intended for such a requirement. And we found solutions and we've delivered them, and so this is a real value add. The customer doesn't have to upgrade their network. And we have a wide list of devices supported already, Ramit will cover. And we have a rolling release every 3 months as our cadence for this product. We keep on adding as we go. So it's very exciting. Basically unlocking the power, the latent power they already have in their hardware, in their software, via this application, really harnessing it. I got 2 slides to show what we do under the hood. For instance, we set our trust boundaries optimally. We set policy enforcement points optimally. We might have even multiple policy enforcement points in the network. That's where we do our own marking policy rather than just accepting or rejecting a given marking. Because, for instance, most of our switches can only identify traffic up to layer 4. Well, TCP port 80, well, that's layer 4, and that can carry thousands of different applications. So you need to look deeper. So where we have the ability to use, for instance, our NBAR technology that sees all the way up to layer 7, then we're going to do an even finer classification policy. The guiding mandate is we do the best that any given platform can do to express your business intent. So we're completely aware of every platform's abilities and capabilities and best practice designs, and then we're going to turn on all of the features that directly contribute to expressing the business intent within that hardware software capabilities. So this slide I like too. And the other thing we do, like I said, we have about 50 different hardware queuing structures across our Catalyst and Nexus platforms. You don't have to wrestle with them. Our customers won't have to wrestle with these anymore. Whether it's wired or wireless hardware or software, we can have dedicated queues. Or whether, we're connecting to wireless networks, because wireless is a completely different animal when it comes to QoS. So it's not, you have no dedicated queues, you have no priority service, no bandwidth guarantees, everything is random. There's only 4 levels of service, and it's a shared media that's half duplex. That's a real bottleneck. It's the second most common bottleneck in the enterprise. The first bottleneck is right here at your WAN, because you're down speeding from campus speeds to probably a factor of at least 100, sometimes more, to go over your WAN network. The second most primary bottleneck is then your wired to wireless edge, because the overall throughput drops significantly. And again, the main reasons for that is because, first of all, you're going to have a downshift in speed, as well as you're going, instead of full duplex, sending and receiving at the same time, now it's half. It's like a one-way bridge, one-lane bridge, where, traffic can either come in one direction or the other, but not at the same time in both directions. And it's completely shared. If you have 200 clients on that network, each one of those clients is contending for that same media, and they're all sharing, and they're all randomly transmitting or attempting to transmit and then backing off, etc. So this is a critically important area to enable QoS, and it's not that often turned on. So we want to make sure that all the right things are happening there. It's being done, properly and efficiently and easily for our customers. So here's our choice. Here's a policy that would be pushed out to a 3650 switch before it has NBAR capabilities. It's 632 lines. If you prefer to type that in, absolutely. You want me to animate that again? All these access lists and entries, and we identify all these different applications. We do classification policies, marking policies, queuing policies. We tune our buffers. We tune our weighted tail drop thresholds.
You can do it that way. Episode 4 at the beginning of that.
What's that? Yeah,
exactly. Star Wars episode 4.
Something like that. Yeah, exactly. So you can do it.
It's hard to deploy this in a meaningful way, which is something that Jordan said, and customers have said that the cost to deploy this properly exceeds the cost of buying more bandwidth sometimes. I've had that comment.
Oh,
that's true.
Easily in a lot of cases.
Right. So, and we all know this. We need this. Even if we have more bandwidth, that doesn't fix the problem. You still need this, but customers buy more bandwidth to get around the fact that this is that hard.
Bigger routers, bigger switches, more bandwidth.
Could I speak to that for a second?
Please.
Because I had a 10-year argument with the vice president at Cisco.
There's
a guy on Twitter right now that's literally screaming at his iPad while watching this session.
Yes. That would be Pharaoh.
Yes.
Yeah.
about
Yeah.
why do I need QoS in the campus? And incidentally, when we first rolled out IP telephony, we did not enable, the IT department says, we're not enabling QoS in our campus. That's too complicated. We're so over-provisioned. We get all our gear at a deeply discounted rate, so we throw bandwidth at it, and we don't even think twice. So why on earth should we care? Okay. Bandwidth and utilization is not an accurate way of assessing if there's a QoS problem, because I'm going to show you the math behind that. The problem is microbursts, and the faster the speed of your network, the more often this can happen. And I'll show you one more thing that's a problem. Let me explain this first. So this is one of our deepest per port buffer modules available to us. It has 5 meg of per port buffering capabilities. In contrast, this Doppler ASIC that I hold, it's got only 6 meg, and it's shared across 24 GigE ports plus 2 uplink ports. 6 meg for 26 different ports, 2 of which are 10 gig. This has about 6 meg for a single port. A lot of buffering. Okay? How much congestion can that accommodate? If I have congestion targeted at one of these ports, one queue, how long before I start dropping packets? 11 milliseconds. Okay, 11 milliseconds, and if I look at my time slice, well, 11 milliseconds is it's about 1%. I have 1% bandwidth utilization. I have a microburst. I'm dropping packets. High definition multimedia packets are sensitive, so sensitive to drops that one packet dropped in 10,000 can be discernible by the user. Here's the math. Let's go into math. Absolutely. For instance, if you work out the numbers, 1080p for instance by 1920, 16 frames per second, every frame if you did not compress would be 3 gig. Now, I love that from the perspective of being a network vendor if people didn't compress video, because they'd have to buy really, really, really big pipes. But we compress video. But when you compress information by 99.8%, and then you drop a packet that's compressed by that ratio, that error of what's dropped is magnified proportionally. We can conceal the loss for packet loss for voice. We set the target for now 20 years, 1%. You drop one packet in voice, what we do is we conceal that. We play out the next voice packet, so it's 50 millisecond. Is it 50 millisecond? No, it's 50 packets per second in 20 millisecond increments. We play out the last 20 milliseconds, and we conceal the loss. You lose 2 packets in a row, you got an audible clip in the conversation. So we say, voice, the target there is 1% packet loss, but if you drop 1 packet in 10,000, you can see it visually as a user. You can see an artifact on the screen, and you can discern that. So it's 100 times more sensitive to packet loss than voice.
Well, most of your compression is based on differences.
Right.
So if you lose it, you've lost the differences, and you have a major artifact.
There you go.
So you have the next full frame.
Exactly. Exactly. So if you're dropping, and you can only buffer, and video is extremely bursty. Here's another chart that I didn't show. So voice, even though it was a challenge to put voice on our data networks, this was 20 years ago, it was a very well-behaved real-time application.
Yeah, reducing the keyframe times even more to try to save that bandwidth.
Exactly.
If the keyframes are that much further apart, you have to drop that much less packets if your keyframes are so far apart.
Sure.
Yeah.
And so video, the randomness, because it varies according to what is actually in the image. And I'll tell you one more thing. When we were doing testing on telepresence, we were doing all this baselining in our labs in RTP, and they have beautiful labs there in the middle of forests, and they have windows, just like here, an entire floor-to-ceiling windows down one side of the labs. Usually our labs are just fully enclosed in San Jose. And we were doing all this baselining and benchmarking to say, okay, this is where we're starting from. And one day to the next, our numbers were completely off. And it was funny too, because to try and drive video utilization rate, I bought everyone on our team ugly Hawaiian shirts, and we would have to wear the Hawaiian shirts, which are harder to compress by the video codecs, and we were dancing around and trying to make as much motion and make it hard for these video codecs to drive those numbers as high as we could. And then one day to the next, our numbers were off by by a huge scale. And we're like, who touched our gear? Who changed our setup? This is where we were the whole week. We were working like this, and now our numbers are completely off. Somebody had opened the blinds and let a little bit more light into the labs, and that threw everything off. The point being, this varies by so many factors that you cannot accurately predict what's going to happen. So when you have bursty traffic that's incredibly drop sensitive, that you can drop packets at 1% utilization, you need QoS in the campus. And then some people say, well, I have line cards that have 90 meg buffers. Okay. Now we got 20 times the buffering capacity, but it's a 10 gig line card, so 10 times the speed, and double the amount of queues. We got a lot of canceling going on. You're still dropping at about 10 milliseconds, or put another way, you're dropping about 1% utilization. Now, the scary thing is, too, is that you're often dropping silently. Now I'm going to come back to my presentation and elaborate on that.
Drops.
So for instance, on this particular chip, we use modular QoS CLI, right? That was the syntax for QoS that was written originally on the routing platforms. Routing platforms all have dedicated queues. This doesn't have any such thing. It has a shared buffer architecture. Otherwise, it would be cost ineffective. It would, if we had dedicated queues at this access switch level, it would be cost prohibitive for our customers to buy such an ASIC for their needs. So we share the buffers, and we don't have dedicated queues, but rather shared buffer queues. And as such, the MQC syntax in the MIB cannot capture some of the information that's happening in the hardware. It's just an incompatibility at the software level, meaning that you could be having drops happening within your chip that are never being reported. You do a show policy map interface, you're never going to see any drops or even any packet statistics on a per queue basis because it's just that incompatibility. So we talked about how real this is in the campus, and then it's not only happening, but you can't see it. That's a problem. So we want to fix that. So the next part I'd like to talk about is how we want to round out this solution to fill in this box of the DNA architecture. And this is very much work in progress in its early days, but at least I would like to share what our thoughts are, get some feedback, get some direction and guidance, and then say, hey, you know, either we're heading in the right direction or redirect us, okay? So the idea here is that, okay, we want to perform abstraction in two directions. We've already talked about taking the business intent, abstracting that into CLI, but now we have all these counters, all of this information from the network that if we just present that, the customer feedback that we shared at the beginning, it's just data overload. It's too much noise. We can't make any sense of it. So we have to extract meaning. So abstraction, but in a reverse direction. To say, okay, if I get all these counters, what are they telling me? How do they relate to my business intent? Have I delivered my business intent? And if so, how well? Or how, if not, where or why not? So this area we're calling validation of experience. Now, just like QoS, oh, actually, let me show one more slide. So the idea is that if we define our business intent, you don't have to be CCIE to configure QoS anymore, because we'll abstract that and program the devices with all the recommendation. This is where we are right now. And we kind of leave it up to our end users to figure out if that intent has been delivered, whereas what we need to do is close that loop and say, okay, now take all that information from the network and correlate it back at a level that the operator can understand and appreciate. Again, they don't have to be CCIE. They don't have to understand what the jitter values of network management application are expected to be, or whatever other metrics we're throwing at them. They shouldn't have to decipher those.
Now, in the previous session, the Stealth Watch technology, they were talking about machine learning for watching the security analytics and reporting that up. Are you looking at doing the same sort of thing to bring that analytic up and see where the validation of experience is?
Yes, so that's exactly a complementary. So analytics can serve many different purposes. There's many types of policies. So security policies, that was one application and role and solution that we're running after. And then a complementary one then is application performance or validation of experience. However, we're going to finally name this, but basically the whole idea is that the same overall approach and I'll show the functional view of the architecture to get to that point. But again, it's just analytics for a different type of policy. So the first thing that we have to do, just like QoS, there's no one single technology. It's an architecture of technologies, some in the hardware we talked about, some in the software, some at the controller level, management level. Same too if we're going to validate this experience. So we have to, first of all, make sure we're collecting all the right things. We cannot have silent drops in our hardware that are not being reported. We have to instrument that, because if we analytics, you just mentioned analytics is only as good as the information that's being supplied to that engine. If you're not supplying a vital piece of information, like I'm dropping packets at this chip, well then I will not get to my root cause analysis without a vital piece of the puzzle.
And only if it's complete.
Yeah.
If we're doing analytics at 1/3 of the network locations, you lose context. So it's important to have all of the analytics from all of the pieces so that you can correlate that.
Exactly.
So it's the correlation.
You're already ahead of me. Awesome. I love it. So starting with instrumentation, and then we not just want to instrument the network, but our endpoints as well. For instance, our Jabber clients do rate adaptive codecs, and they monitor network conditions, and they say, oh, now lower your resolution, or lower your frame rates, or increase your compression, or do all these tips and tricks to try to get a level of quality that the network can handle in the current state. And then they monitor all that information, but then as soon as they made a decision, they throw it away. And it's like, hey, let's hang on to those information, because it's very valuable to give us an entire picture of what's going on. Excuse me, not only at the network level, but your quality of experience level. What are you experiencing as a user that is even beyond what's happening at the network? So collecting the right metrics. The second part then is that not every metric we collect is equally important. So before we start responding to them, let's do some analytics on the device itself to say, oh, okay, this is a problem over here. This other thing, well, it's just kind of informational, and we're going to keep tracking it, obviously, but some of these elements might be very critical bits of information. Then we want to make sure we get those critical bits of information off the devices. Don't just leave them there until somebody has a problem and then now has to investigate. But if you got a critical message or a critical event, get it off. So send it up to an analytics platform or some other repository. We're working on this architecture and we're building it out. But the key point here is to have efficient, effective telemetry. SNMP mid polling doesn't meet our needs anymore. We have to have something more effective. Again, this would be great if it's model driven, because then you could have a lot more flexibility in correlation as well as multi-vendor support. Another need we have is real-time monitoring. For instance, we were doing some demos we did about 8 or 9 demos as part of our QoS 5.0 Tectorial on Sunday, and one of the things we wanted to demo and make a change, we said, okay, if we make this change, it wouldn't be reported on in our management app for an hour. We're like, okay, well that's a lot of airtime to talk through, so we can't have that. So we need a real-time monitoring, both at the network device level as well as at the controller level. Another requirement then is scalable storage. So hierarchical storage, scalable storage, perhaps even using the cloud for this type of information so that you can have all the information from all the different sources in one place. That's key, because now you can perform analytics. Now, with all of that information at your disposal, you could start doing correlation, and you can start seeing, okay, are things happening? Are they normal? If they're not, where are they falling apart? And you can then identify these anomalies. And then you can do a root cause analysis. Like when you have an issue, what's the first thing that the TAC person asks you for? Show tech, right? Pull the rest of the information. You only sent a critical bit of it off the network. Now he wants the full picture. He needs context. He needs to make some additional correlation of what's happening on that device to get to the root cause.
We just need to get
my final slide. Sorry,
we just need to get to the point that they don't ask for it when it's already there.
Okay, good. And then the North Star vision is to be able to enable self-remediation. For instance, with quality of service, the #1 TAC case reports is missing or incorrect classification and marking. Okay, if we know that, we can say, look, you've got an issue with this application. We know, the controller knows where that application is entering the network. Go look for the classification and marking policy. Is it present? Maybe that traffic entered the network on a third-party device or on a legacy device or wherever else. Whatever the reason is it being classified? Is it being marked? Check for that. If it's not there, you can make a recommendation. Say, we've noticed this as a root cause. This is our suggested fix. Yes, or yes always. And if the operator chooses to click yes always, you've achieved self-remediating networks.